The following video is in response to your feedback on my cow. Starting with your question at 10 seconds, I think it's important that these locations are on the same longitude line for this project because this project is showing that the seasons happen because of how the axis of Earth is tilted and how that affects the weather. In my original video, I showed this diagram and I explained how the tilt of the axis affects the temperature of the Earth in different hemispheres. Let's take a look at this diagram I made, which is similar to the diagram I just showed you, but this time the diagram is showing my locations at the date I chose. Let's look at the lines of latitude and longitude. Do you see that different lines of latitude are experiencing different weather? Look at the light intensity. The strongest sunlight is near the middle of the Earth and the weaker light intensity is away from the middle of the Earth. But if you focus in on one latitudinal line, every area on that line will be experiencing a similar amount of sunlight. I mean, yes, half the Earth isn't facing the sun, but remember that the Earth is constantly spinning. Now zoom in on one longitudinal line. All the different points on this longitude line will be experiencing different weather because they are all experiencing different sunlight intensity. So if two locations are on the same longitudinal line but not on the same latitude line, like my locations, they will be experiencing different weather because longitude and latitude is dependent on each other, and longitude determines a location's position on a latitudinal line and vice versa. Look at my locations. They are on the same longitude line but not on the same latitude line, and so they are experiencing a different amount of sunlight. So, you've heard me talk a lot about light intensity, but I haven't really explained what that means. In short, light intensity is the amount of power a given light source is exposing something else to. Light intensity is measured in angles. At first, this can seem kind of like a weird concept, especially concerning something round like the Earth, but let me show you what I mean. In this diagram, the smaller circle is the Earth and the larger one is the Sun. The lines I drew are lines of light intensity. The angle of light intensity on Earth is measured by how the sun/light intensity will be measured from Earth. Let's take this protractor and measure one of the angles of light intensity. When standing on Earth, the shape of Earth does not seem like a sphere, it seems flat, right? So if we draw a straight line at the point we would be standing on Earth, we can measure the angle. The middle of the Earth has a light intensity of 90 degrees. This is because the light intensity wave is directly above that point on Earth. These are the angles of sunlight. Notice that none of these angles are more than 90 degrees. This is because the middle of the Earth is experiencing the most light intensity and the other parts of the Earth are experiencing less direct sunlight intensity. Okay, so now that I have cleared up some of the ideas in the last video, why don't we explore this further? The reason why it is important to discuss these ideas and communicate this concept is because there are often a lot of misconceptions about how the seasons work. In fact, some people believe that the reason for the seasons isn't because of the tilt of axis, but or light intensity. It is because of the Earth's orbit. A lot of people think that summer is caused by the Earth moving closer to the sun and that winter is caused by the Earth being farther away from the sun. As you now know, this isn't true, but what if it was? Let's say that in this fictional scenario, the Earth isn't on an axis and the seasons are caused by Earth's distance from the sun. This would mean that all places on Earth would experience the same seasons simultaneously. The places on Earth are still going to be different temperatures because some parts of Earth are facing the sun more directly, but they will all experience the same seasons. This would also mean that no matter what season a destination is experiencing, the hours of sunlight they are receiving will not change. This is because without a tilted axis, a destination will always be facing the sun in the same direction. Speaking of heat and light, why don't we switch gears and talk about global warming? Global warming, in a brief explanation, is the gradual heating up of our planet due to the increase in carbon dioxide and other greenhouse gases in the atmosphere. This would affect the seasons because if the temperature of the Earth is gradually getting warmer, then so will the seasons. This means we will have warmer winters and hotter summers. This will not change the Earth's revolution around the sun or anything, but it will still affect the temperatures. This can be a little confusing because if the amount of sunlight and heat that is hitting the Earth stays the same, how come the Earth is somehow getting warmer? Well, before we dig into that question, I'm going to ask you a different one. Where does all of the heat that hits Earth go? Obviously, the heat that the sun emits heats up the Earth, but the heat doesn't just stay there, right? I mean, if that was the case, then the Earth would have been gradually heating up this whole time, making it unbearably hot. So no, the heat doesn't just stay there. The Earth also emits heat. The only difference is that the light the sun emits is mostly visible light, and the light the Earth emits is mostly infrared light. Carbon and other greenhouse gases let visible light pass through it, but they often absorb infrared light. Greenhouse gases hold on to infrared light before emitting it, and the lingering heat can cause the Earth to warm up, and this is natural, but when there is too much greenhouse gases in the atmosphere, this can be caused by air pollution and less trees absorbing carbon, the heat lingers more and it is causes a gradual overall increase in the temperatures on Earth. So how does this affect the seasons? Let's focus on winter. Winter is supposed to be super cold, right? There's snow and ice and it's all chilly outside. So what would happen if the temperatures rose? Well, the basic things you would expect to happen would happen. The temperatures would rise a little, there'd be less ice, and I'm sure kids are sad to hear there will consequently be less snow days. What about on a bigger scale? I mentioned less snow and ice, but what about the ice that's already there? I'm not talking about in the U.S., I'm talking about the North Pole and Greenland. These places are full of ice, so what would happen if that ice were to melt? What actually has already started. This is one of the biggest concerns with climate change. This is because if all the Earth is melting, where do you think the water is going to go? The ocean. When all the water is flooding the ocean, not only will the coastal regions start to flood, but the current that brings nutrients to fish and plankton will get messed up, causing ocean life to die and oceanic food chains to get messed up. The currents will get messed up because the frozen water is all fresh water, which is less dense than salt water, meaning the currents will change when the fresh water floats, displacing water, and new currents form, messing up old ones. This makes a huge impact on life on Earth. Okay, sorry, I got a little carried away there. But basically, in conclusion, the seasons are a complex and interesting cycle that is worth digging deeper into. I hope I furthered not only your understanding of how they happen, but your curiosity regarding how we experience the seasons and how that could change.